Alright, hi everybody. Here's your review key for, or video key for your review. If you happen to like the song Better Man by Pearl Jam that I recommended to you, then another great song by Pearl Jam, which there are many, is Nothing Man. You might want to give that one a listen. Alright, so number one, a man starts walking north. And so this picture is kind of weird, but we have a guy walking north this way. He's 500 feet apart from a woman who walks south. And then we're trying to find the rate of change of the distance between them, which is the rate of change of that green line right there. But what you can really do is just kind of shift this around. And if we take this blue thing here where the girl's walking and just move it right here, and then take the 500 feet between them and move it down here, we can actually just form a right triangle in this problem that would look like this. So this distance, let me pause this. Alright, I had to pause that for an announcement. Now that you noticed, because time just seems to go on as normal on the video when I pause it. But in any case, so we can move those sides over, and basically we're just creating this right triangle like this. Because those values, it doesn't matter where I draw them, they're going to be the same values. Like as the girl walks south and this length right here grows, then this length would grow exactly the same because they're the same length. And so then what we have is you can find the distance on the left side of the triangle from the rate and the time that they walk. So you do the man's rate and time, and he ends up going 80 meters, and the woman went 75, so for a grand total of 155. That is not a constant, however. This is 500, and so z, which is also not a constant, is equal to the square root of 155 squared plus 500 squared. And then this is a Pythagorean theorem problem. So this is related rates because we're trying to find the rate of change that the people are moving apart. So you can just use the Pythagorean theorem, x squared plus y squared equals z squared. Remember how I said you don't need the 2's when you do the derivative of this, because I'm going to use prime notation just to save some time. Because the 2's, you can just divide both sides by 2 after bringing the 2's down, and you end up with this. And then, let's see, we know dx dt, or x prime, is 0, because the 500 isn't changing. Or you could have plugged a 500 in to begin with right here, and then the derivative of that would be 0. And then in either case, that's gone. And you just have y prime. Y prime is 9, since the man is walking north 5 and the woman south, or the man is going north 4 and the woman south 5 meters per second. Then that total rate of change of this side of the triangle is those two things added together. So y prime is 9. We know y, we know z. Find z prime. Number 2. Now here it says, hey, find the largest possible volume of a box. That means this is an optimization problem. We're finding the maximum of something. We know this surface area is 1200. It's an open top, so there's just x squared instead of 2x squared. And then there's 4 sides that are 4xh. That's where my picture looks like this. This is how I have it labeled, and this is how I always label it. I call this h, and then the base is x by x. So you get 4 sides. You get this side here is xh, this right side is xh, the side behind here, the back, and the left side are all xh, which is why we have 4xh, and then just the bottom x squared. If it was a closed top, you would have 2x squared. So that is our surface area, which we know is 1200. We're trying to find the largest possible volume of the box. Volume of this is equal to x squared h. So we got to find the derivative of the volume. This is not a related rates problem. There's no dv, dt, or anything like that. So we got to find the volume of the box, find the derivative of the volume, set it equal to 0, find our critical point, and go from there. So use the red equation to substitute into the green equation. So if I solve this, I can subtract x squared and divide by 4x, and that gets me h. Plug h into the green equation, and you get v equals x squared times 1200 minus x squared over 4x. This actually simplifies to be when you distribute, and I split it up into two fractions, it's going to be 300x minus x cubed over 4. The derivative of that, v prime, is equal to 300 minus 3/4 x squared. Setting this equal to 0 to find our critical point, we get 3/4 x squared is equal to 300, which is x squared equals 400. So x equals plus or minus 20, but of course the negative value doesn't make sense for this problem. Plug your 20 into this equation right here, since it's already solved for h. So get your h value, you get h equals 10, and then plug those two dimensions into your volume equation right here to actually calculate the volume, because the problem here does ask us to find the volume. All right, number 3, a very straightforward differential. So dy, the change in y, is equal to 2x plus 2 times dx, when x is 3 and dx is 0.5, so you get dy equals 8 times 0.5 when I plug in 3 and 0.5, and you just get 4. All right, let's see here. I know part of the struggle of these problems when they're all mixed together is like figuring out which type of problem it is. If you're given a rate, it's going to be a related rates problem. Also, it says at what rate is the angle, blah, blah, blah. So you're trying to find a rate. So that's a related rates problem. If it asks you to find the biggest or smallest or the maximum or minimum, that's an optimization problem where you're going to set up an equation or maybe two to use substitution like we did on number 2. Set it equal to 0 to find your critical point, and that's where the max or min might occur. All right, in any case, on this problem, we have a kite that is 100 feet above the ground. At what rate is the angle between the string and the horizontal changing when 200 feet of string has been let out? So we know at the moment in question this is 200. From Pythagorean theorem, we can get this to be the square root of 30,000. We know x prime, or dx dt, is equal to 8, and we're trying to find d theta dt. And so probably the best thing to do is use anything that's constant if possible, because we're going to set up a trig equation. There's, of course, 3 different ones we could set up. So I'm going to use anything that's constant. So I'm going to use the 100 for sure. Then I'm going to use the other side I'm going to choose as the side that I know the rate of change of it. I don't want to use z in my equation because it will have z prime in the derivative, and I don't know z prime. You could find it from Pythagorean theorem if you really wanted to, but you might as well just use y and x since you already know dx dt. And so I'm going to use tangent of theta equals 100 over x, and therefore secant squared theta d theta dt is equal to, so make 100 over x 100x to the negative first, and do power rule. So it's going to be negative 100 over x squared, or x to the negative second, times dx dt because of chain rule. To find secant squared, remember, just find your cosine value from your triangle. So cosine of theta is adjacent over hypotenuse, and then square that to get cosine squared, and then flip it to make it secant squared. Okay, and then you can plug that in. We know everything except for d theta dt. So you can plug this, after you flip it and square it, that goes there. This is what we're trying to find. X is a known value, it's square root of 30,000, and dx dt was given to be 8. So just plug and chug. You can look at the actual key for the final answer there. All right, on number 5, it says what dimensions will give the largest printed area. So that's telling you right away that you're trying to find, this is an optimization problem. You're trying to find the maximum or minimum of something. There are 2 different ways you can do this. The way I did it is I called the big dimensions L and W. You could call the small dimensions L and W. And then we have a 2-inch margin at the top and 1 everywhere else. So it's going to look something like this, where from here to here is 2, and everywhere else is 1. And so the smaller dimensions, which we're trying to maximize the printed area, which would be my blue rectangle. So that area is going to be L minus 3 times W minus 2. And it's L minus 3 because this is 2 right here at the top. This is a margin of 1 right there. This is 1. And this is 1 from here to here. Come on, let me write it. You can see a nicer picture on the handwritten key. It's really hard to draw things, I think, on this app. All right, and we know that the total area of the whole poster is 180. And that's equal to L times W, the way I drew it. And so I can use this to substitute, get W equals L over 180. It doesn't matter if I solve this for L or W, it's going to work out this roughly the same. I mean, that's 180 over L, sorry. (180 over L). Substitute that for W into the blue equation. So you get A equals L minus 3 times 180 over L minus 2. Distribute to make that a little easier. So the area is equal to 186 minus 2L minus 540 over L. Find your derivative. A prime is equal to negative 2 plus 540 over L squared. Again, that's just making this 540 L to the negative first and doing power rule. Solve this, you get L squared equals 270. Square root both sides, it gets you L, and you can look at the handwritten key for the actual solution. All right, you do not need to know how to do numbers 7 or 8. That's stuff that I actually removed from the problem set and forgot to remove from the key. I mean the review, so sorry about that. All right, number 6, we have a spotlight on a ground 12 meters away, so shining up on a building. So here's the building. 12 meters away, we have a spotlight. So we know that whole distance is 12. There's a man 2 meters tall. The spotlight is hitting him and then casting a shadow on the building. I call this distance x, and then therefore this is 12 minus x. You could flip-flop that. That doesn't really matter. If you did flip-flop it, your equations will look a little bit different. The unknown height of the shadow is y. We know the man is 2 meters tall. And we're trying to find the rate of change of the shadow, so we're trying to find y prime. So you can set up a proportion. I did 2 over 12 minus x equals y over 12. Cross multiply and you get 24 equals 12y minus xy after you distribute. You can find the derivative of this now. And you get 0 equals 12y prime minus, got to do product rule here, so x prime y plus y prime x. What else were we given? We know he's walking towards the building, so the way I labeled this, since he's walking towards the building and my x is this distance is decreasing, so my rate is negative 1.6. If you called this distance x, that would be increasing, and so you would have a positive rate there. But my x prime is negative 1.6. Negative 1.6. And so we know x, or what do we know? We know x. You can find y by using this equation when x is 4. So plug in 4 for x, solve for y, and you get y equals 3. So we know x prime, we know y, we know x, and we're trying to find y prime. So just plug everything in and solve for y prime. And then finally, number 9. Now this one is more for the setup of the problem. The derivative would get kind of crazy, so I just said you can just actually find the minimum on your calculator. But this is an optimization problem, but it does use similar triangles. So we have a fence. We have a building here. And then there's a fence that's 8 feet tall running parallel to the building. Like this. And we're going to lean a ladder that will go over the fence and reach the wall. And what is the length of the shortest ladder that will reach? So we're trying to find, I'll call the ladder L. So we're trying to minimize L. So we need an equation for L. Call this H. We know that the fence is 4 feet from the building. So that's 4. This is an unknown distance x. And we know that the fence is 8 feet tall. So from this, we know that x plus 4, setting up a proportion over h, is equal to x over 8. And we need that because we know L from Pythagorean theorem is equal to the square root of h squared plus 4 plus x squared. So to get our equation for L into a single variable, you can solve this for h and then plug it in for that h. And so from here, we know that xh, just by cross multiplying, xh equals 8x plus 32 when you distribute. And so h equals 8x plus 32 over x. Take that, substitute it right there for that h. That's your function. And then for this particular problem, because the derivative is kind of crazy and who wants to set that equal to 0, just go ahead and solve that graphically. And that is it.